Summary. A configuration server built with Spring Cloud Config Server can be protected with any of the features offered by Spring Security. For example, you can require a client to use HTTP basic authentication to access the configuration endpoints exposed by the server. Configuration data in a Spring Boot application can be reloaded by calling the /actuator/refresh endpoint exposed by Spring Boot Actuator. To propagate the config refresh operation to other applications in the system, you can use Spring Cloud Bus. Spring Cloud Config Server offers a monitor module that exposes a /monitor endpoint that code repository providers can call through a webhook whenever a new change is pushed to the configuration repository. The result is that all the applications affected by the configuration change will be triggered by Spring Cloud Bus to reload the configuration. The whole process happens automatically. Managing secrets is a critical task of any software system, and it is dangerous when mistakes are made. Spring Cloud Config offers encryption and decryption features for handling secrets safely in the configuration repository, using either symmetric or asymmetric keys. You can also use secrets management solutions offered by cloud providers like Azure, AWS, and Google Cloud, and leverage the integration with Spring Boot provided by Spring Cloud Azure, Spring Cloud AWS, and Spring Cloud GCP. HashiCorp Vault is another option. You can either use it to configure all Spring Boot applications directly through the Spring Vault project or make it a backend for Spring Cloud Config Server. When Spring Boot applications are deployed to a Kubernetes cluster, you can also configure them through config maps for non-sensitive configuration data and secrets for sensitive configuration data. You can use config maps and secrets as a source of values for environment variables or mount them as volumes to the container. The latter approach is the preferred one and is supported by Spring Boot natively. Secrets are not secret. The data contained within them is not encrypted by default, so you shouldn't put them under version control and include them in your repository. The platform team is responsible for protecting secrets, such as by using the Sealed Secrets project to encrypt secrets and make it possible to put them under version control. Managing several Kubernetes manifests to deploy an application is not very intuitive. Kustomize provides a convenient way to manage, deploy, configure, and upgrade an application in Kubernetes. Among other things, Kustomize provides generators to build config maps and secrets, and a way to trigger a rolling restart whenever they are updated. The Kustomize approach to configuration customization is based on the concepts of bases and overlays. Overlays are built on top of base manifests, and any customization is applied via patches. You saw how to define patches for customizing environment variables, config maps, container images, and replicas.